All right, so now what we're going to do is it's called ray tracing. So basically, you buy a lens or a mirror, and when you buy a lens or a mirror, you buy them according to the focal length, and I'll define that in a minute. So you buy a certain lens or a mirror with a certain focal length, and then you know where the object is relative to the lens or the mirror. So what your job is to find where the image is, and what kind of image. It's going to be up or inverted, upright or inverted. It's going to be magnified or whatnot. And so again, first we're going to learn how to draw the ray diagrams, and then every situation that we're going to draw we'll do later on, we'll solve later on with the math. Okay? So here we go. So we'll do lenses first because they're easy, and we'll do mirrors later because they're a little bit more difficult. All right, here you go. So this is a lens because the light goes through it, right? Mirrors, it reflects. So here's a lens. So the object is far away, so you can just assume that the rays are parallel, okay? This is called the optical axis. It's a straight line. And you can see that, what does the lens do? The lens focuses those parallel rays. So what kind of lens is that? It's a converging lens. That kind of makes sense, right? Because these parallel rays converge to this point. Okay? So converging lens. Now, this distance here, so you're basically going to pretend that this lens is infinitely thin, all right? So just pretend there's a straight line here. So the distance from like here to here, which is the same as here to here, that's called the focal length. F, the focal length. And that's how you buy lenses, right? You specify the focal length you want. Okay? So this is the focal point. Rays of light actually converge at this point. So this is real light, real light, okay? All right. What kind of lens is that? The other one was a converging, but here you have the incoming rays. What do? They diverge, right? They go, right? They diverge. So what are you going to call it? A diverging lens, right? Okay. So again, remember, well, let's go back. Okay. So again, these are the outgoing rays. And you always find your image by figuring out where the outgoing rays intersect, which is right there, right? That's the image point, or the focal point. The focal point. Okay, here, gosh, what happens? So here you have these parallel rays. They diverge. So where's the focal point? So I have to backtrack, right? So this is the focal point. Okay, that's the focal point. Rays appear to diverge from this point. So we have a diverging lens, focal length. Now, when we draw these dotted lines, is it real light? No, it's not real light. Okay, it's not real light at all. Okay, that's why it says here. This is the focal point. Rays of light appear to diverge from this point. Okay, appear to diverge from this point. All right, so let's do it. All right, so there's a lot of conventions. You don't have to memorize. I mean, you'll have a table on the test, and when you do all your homework problems, I would recommend you have a copy of the table right in front of you. It'll help you a lot. So here's the first convention. Whenever you have a converging lens, the focal length is always positive. When you have a diverging lens, the focal length is always negative. So right away, if you know the focal length, you know if it's converging or diverging. All right, so this is all you have to do. All you have to do. So typically, they're going to give you a lens, right? Converging lens. They'll say the focal length is whatever, 0.2 meters or whatever, 2 centimeters. Who cares? Positive for converging. Then they'll tell you the object distance from here to here, and again, here's the focal length. So all you have to do to locate the image is to draw these 3 lines and see where they intersect, or these 3 rays. Sorry. All right. So here's the first one, and you kind of want to. You have to learn this, okay? You have to remember this. I'm not going to give it to you on the exam. and you're going to use these again and again and again. So you really, for mirrors, so you really want to remember them. But they're easy. All right, so here's what you do. You draw the lens. Just pretend it's a straight line, perpendicular to this line. You draw your object. I don't care how big it is unless they tell you, but just draw an object. Make it big. Who cares? You draw your focal points, both sides. All right? And then here you go. So you go from the top of the object, parallel in, and then focal point out. Right? That's easy to remember, right? Parallel in, focal point out. So there's one. Let's do this one. Focal point in, parallel out. Right? Focal in, parallel out. That's just how I remember it. Okay? Now look at the image is going to be at the intersection of this and this. Well, how many lines do you really need? Just two. So you just do the third one just as a check. The third one's the easiest. It doesn't. You just go right there. Just go straight. Okay? So that's it. So where this and this and this, where those outgoing rays intersect, that's where you'll find the image. All right? So how I remember this is, like I said, parallel in, focal out. Focal in, parallel out, and then just a straight line through the center there. And that's really all there is to it. Now, it's really not all that easy, but pretty much it is. So we'll do a lot of examples. And I think I said it already. It's best if you do this with graph paper. You kind of want to do a pretty good job. All right, so here we go. Are you ready? Now, I don't have graph paper. If we were in, whatever, one of the classrooms has a whiteboard with a graph paper, but we don't have it, so we're just going to wing it. All right? Okay. So here we go. All right. Close enough. Okay, so there's the optic axis. Here's the lens. You just don't be too picky. So there's the lens. It's a converging lens. Okay, so you got to come up with a scale, right? You got to come up. I mean, you have to make these drawings scale drawings. All right. So the focal length is 10 centimeters. All right, so I'm going to just, oh, this is a horrible ruler. So I'm going to just say, let's see. All right, so that's 10 centimeters that way, and then, yeah. Okay, so that's 10 centimeters. That's 10 centimeters. All right, and then this is the object. Remember, the S is the object, 25. Okay, so let's see. So that was 10, 20, 25. So there's 25. And don't just make it big. So just make the object big. So that's the object, all right? So this is the lens. This is the object. All right. Now just do it, okay? So let's do this one first. All right, so the first one is parallel in, focal out. So what's this in, out? I mean, in is coming toward the lens, out is going away from the lens. That's what I mean. All right, so again, lens, focal points, object. Okay, now again, I don't have a graph paper, so I don't know if this is going to be perfectly parallel, but I just do our best. So parallel in, and then focal out. Whatever. All right, so that's this guy. Now this guy, focal out. So again, to the lens, right? So, I mean focal in, sorry. Focal in. So focal in. Then it gets to the lens, and it's parallel out. Something like that. right? So that's number 2, right? Focal into the lens, then parallel out. Third one, you gotta love the third one. It's the easiest one. Oh man, maybe I made my okay. It's gonna work. I don't. What do you know? I have to cheat a little bit, but so there's the third one, just straight. There you go. And you see that they intersect right here, right? Okay, so that's awesome. So now what you do, that's the image. So that is your image. So, all right, so that's the image. Okay. So what do you notice? Okay, so what do you notice? All right, so let's discuss this in gory detail. Number 1, this is a lens, right? So this is real light. I didn't have to do any backtrack or anything like that. This is real light, right? So it's real light. So it's a real image, right? No backtracking, no dotted lines. Okay, now here's a convention. Again, you just better get your tables from the book. If it's a real image, okay, so sorry. This is S, right? This is S, the object distance. This is S prime, the image distance, right? It's really from here to here, you know. So object, image. Now here's, okay, if it's a real image, S prime is positive. What it means is that the image is behind the lens, right? So the object is on one side of the lens, the image is on the other side of the lens. I guess that's a better way to say it. The object was this way, correct? The image is that way, so it's an inverted image, upside down. Yeah, that's what it means, upside down. And we're going to learn, okay, whatever. And so the magnification for inverted image, the magnification is defined to be negative, right? Negative. All right, let's see, what else? So let's see. So we have S prime is positive, S is always positive. So look at, so S prime is positive, S is positive, so the magnification is negative. Yep, we agree, it's inverted. So there's really 2 ways of calculating the magnification. This is the easiest one, but you can do this one too, you know. Let's do that one. So that one, you really need graph paper, and you need to be careful. So this is the height of the image divided by the height of the object. And this is only absolute value, right? So this doesn't tell you if it's inverted or not. So H prime, oh golly. So H prime is about 6.5, whatever. So H prime, I'll just say 6.5 centimeters. And then, so A and H is, and again, you just draw this, you know, initially. You don't care, you just draw it. And it's like 15. So H is like 15 centimeters. So the magnification is just absolute, well, whatever. Absolute value of magnification, H prime, 6.5 centimeters divided by 15 centimeters, whatever that is. Okay? So, I mean, it's less than 1, right? It's less than 1, okay? That's not bad. So that's how you do it. And so, you know, what you do it with your meter stick, you know, you'd measure this, right? That would be S prime. Any questions? You can't ask questions. Yeah, you can send me an email. I've only had one person sending me an email the whole semester, by the way, which is okay as long as you're talking to our tutor, but don't feel bad about asking questions. It's a good thing to ask questions. All right, so there we go. So this is the easy one, I'll be honest with you, all right? I should find the answer for this. Let me find the answer. So let's see. So it's 10. So S prime is about 16 centimeters, about. Okay, when I did it really nicely on a piece of graph paper, and I was super careful, I had S prime was 17 centimeters. That's not bad. So, and these were pretty close too. All right, let's do another one. Because again, you're gonna be doing this soon enough. All right, let's do this one. Okay, so, small focal lengths. All right, let's see. Okay, so there's the lens. Focal length is 5 centimeters. So 5 here, 5 there. Object is 20. Oh, and let's make it big. It's just nice if you make the object tall, because then you just get better results. I mean, if it's really short, then it's hard to get good results. So let's make it big. There. All right. So there's the object S, focal length. Let me just check something real quick. Yeah, I did okay. That's okay. All right. So there we go. Okay, so first ray, number 1, parallel in, focal out. Oh, golly. I wish I were tall. Parallel in, focal out. Ah, gee. Whatever. Okay, second one, focal in, parallel out. Okay, so I'm really done, right? I mean, I know that that's where the image is, right? I mean, because it only takes 2 lines. But you just do the third one for a check, just to make sure you didn't goof up. So third one. Yeah. Okay. So okay, so that's S prime. So let's see, according to me, so S prime is about 26.8, something like that. 27, whatever. Let's just say 27. It's about 27 centimeters. Okay, that's all there is to it. So, wait a minute. What do you mean 27? I mean, sorry, 7. God, sorry, 7. Yeah, 7. This was 5, so it's about 7. Okay, let's do it. So, magnification. Okay, first of all, it's a real image. So it's a real image, right? Real image. So real image. So S prime is positive. Okay. So magnification is minus S prime over object, which is like about a third, right? It's about a third. No, that's about a third. About, right? Let's do it this way. So this is 30. This is 10. So 10 over 30 is about a third. Woohoo! All right, anyway. There you go. Okay, now let's do a harder one. The problems where the object is outside of the focal length, those are the easy ones. By the way, I have to apologize. I wasn't supposed to do this. You were supposed to do this. So I goofed up, right? So just do it on your own, please. You got to get used to this. Okay, let's do a more challenging one. Oh, wow, look at that. There it is. That's right. So that's a nice job. Right? Here's what I did on the board. So I just guessed 7 centimeters. When I did it nicely, I get 6.8, close enough, right? And the magnifications, 0.325, 0.34. I just guessed at about a third. Pretty close, right? So there you go. Okay, now let's do the hard one. Oh my gosh. Okay, here's the tough one. See, now the focal length is 25, but the object is only 10. So now the object is between the focal length and the lens. That's a bit more challenging. And here's my hints, and I think it's good. First, draw the easy one. And then draw either one or two. Doesn't really matter. So let's do that one. So the beauty of what we're doing is we're learning how to solve these problems graphically, and then we're going to learn how to do it mathematically. And so if you're smart, which I assume you are, you solve the problem both ways, and then if you get agreement, you know you did it right. If you don't get agreement, you know you did it wrong. So it's awesome, right? It's a totally great way of doing it. All righty. Number 3, oh golly. The worst part of these ray diagrams is making sure you don't get off the paper. You'll learn that when you start doing them. All right, now. Okay, so focal length is 25. Oh boy. So there's an F. Ugh, F. F. So there's that. And then the object is 10. Okay. And here we go. So, all right, so there we go. There's our object. So the first thing we're going to do is just do the easy one. Okay. All right, so that's the first one. Okay, now what we want to do is, it's our choice, right? Let's do 1. So parallel in, focal out, right? Parallel in, focal out. Okay, no problem. So parallel in, focal out. Just like before, it's nothing new. Okay, so there's an outgoing, and there's an outgoing. Now, what do you notice? I mean, for the previous ones, you know, these were the outgoing, right? And they intersected right here. That's where the image was, right? Just like the, oh, I guess I didn't draw it. Lazy, okay? But now, you know, here's the outgoing, here's outgoing. It doesn't intersect anywhere here, right? Well, that's kind of a bummer. So what are you going to do? You know, what do you do? Maybe we should draw this one too. How do you do this one, though? How do you do that one? Because that one says focal in, parallel out. Well, how do you do that? Well, you do it like this. So there's the light, right? So there's the light. So, I mean, you're aiming at the focal. Hope you can see that. So there's the light, and then parallel, right? Focal in, parallel out. Something like that. I don't know. Okay, so we have these 3 outgoing rays, which certainly don't intersect here. So what do we got to do? We got to backtrack. Let's see if I did a decent job. So you backtrack with the dotted lines because it's not real light. Not such a hot job, whatever, somewhere around here. Okay? And there is your object. I mean your image, sorry, image. So there's your image. Okay? So that's how you do it. Kind of complicated, right? So let's see if I did a nice job. Yeah, I did a nice job. Okay, good. Okay, so again, focal, and then your object. Okay, ray 1, parallel in, focal out. The easy one, you just draw straight through. The other one, it's focal in, parallel out, so you kind of have to hold your ruler like this, right? Right? So here's the light. The real light is from here to there and then parallel out. So you have these 3 outgoing rays which do not intersect over here. So you have to backtrack, and they focus right there. So there's the object. Okay? So, I mean, why I keep saying that? This is the image. This is the object. This is the image. Sorry. So, is this image formed with real light? No, it is not. We had to backtrack. So this is called a virtual image. I mean, your eye, your eye doesn't know the difference, right? It's the image, right? But I'm just saying we're differentiating between them. So it's a virtual image. So since it's a virtual image, it's on the same side of the lens as the object. We give it a minus sign, and you have to give it the minus sign, or else the math later on won't work. Okay. All right. So you got to do it, and then then you can just use these formulas to figure out the magnification. Okay. Hopefully, I have one for you now. Nope. Darn. Well, you just make sure you can do all of these 3, right? You have to be able to do these 3. And of course, I'm not going to give you a super easy one on the test. I'm going to give you one that's a little challenging, Okay, so 1, 2, and 3, they all had positive focal lengths. So they were all converging lenses. Now what we want to do is we want to do a diverging lens. Okay, diverging lens. Not so bad. So first thing I want to remember, diverging lens, negative focal length. And so, the test question or the homework question might say something like, a diverging lens has a focal length of magnitude 2 centimeters or something like that. You have to put in that minus sign if they don't tell you, okay? All right, now here's the beauty of it. What do you notice? Parallel in, diverges, but look, if you backtrack, focal out. Huh? Just like before, sort of. This one, focal in, if you whatever you want, right? Focal in, parallel out, sort of like the last one. And then you get our good old friend number 3 again. So, I mean, they're a little bit different, right? These 2 are a little different from what we had with the converging lens, but they're sort of similar too. So we got to do one, then we'll stop. Okay, so actually I want you to do it. So here, all right, so this is a diverging. So notice there's a minus sign, so as soon as you see that minus, it's a diverging lens, right? So just use these 3 rays and just use your head and what we've done in the past and figure it out. So you figure that out while I erase. So pause your video and do it. All right, so we're back now, and I assume you did it. So let's me do it. All right, focal is 10. Oh man, it's going to go way over there. Gosh, okay. All right, let's see. What? Sorry. There's a focal, and then how big will I make it? All right. Okay, so diverging. I don't know. I just remember that. Right? Focal, 10, 10, 25. Okay, you ready? Let's do it. All right, first one. Parallel in, focal out. Parallel in. Now it's diverging, so it's going to diverge, right? So, but focal out though. Okay. All right, that's the first one. Let's do the third one. It's always easy. And the second one, so you aim at the focal, you aim at this focal point. So it's focal in, but then you hit the lens and you go parallel out. Okay, so you have these three outgoing rays. So what are you going to do? You're going to backtrack, right? So you backtrack this guy, backtrack this guy, and this one you don't really need to do. So where they intersect, somewhere right there. So there you go. Okay, so real or virtual? It's virtual, right? It's virtual because the object and image are on the same side, you know. So it's virtual. It shrunk, right? So okay, this is upright because it's both. I mean, this is up, so it's upright. Here's the object. The image is shorter than the object, so it shrunk. So the magnification is less than 1. So let's look at it. Hey, that's pretty good, right? Doesn't that look pretty much the same? Oh, I forgot to measure it. Let's measure it. See if I really did a good job. Yeah, it's like 7.2 or something. So here, like S prime is like 7.25 or something like that. And here I had 7. Oh, it's minus. Sorry, minus. Here I had minus 7.3. It's pretty good. So see, upright. I mean, it's upright, and it's much shorter. Upright, it's much shorter. So good job. All right. So there you go. Okay. All right. Let's quit.